Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this our today's session on the cycloalkanes. Here in this video we are going to discuss about the second part of the Baeyer strain theory. Already in first video we have discussed what are the assumptions that he has considered while proposing this Baeyer strain theory. Also we have seen what the statement that he has given, that is the higher the deviation from the normal bond angle value, that will produce the larger strain in the molecule. Higher the deviation, lesser will be the stability. Also we have checked how to calculate the deviation in the bond angle by using the formula. So in this video we are going to discuss about what are the different effects of these deviations on the stability and reactivity of the different cycloalkanes. So let's begin with our today's session. Before that, if you are coming first time to this my YouTube channel, watch my previous videos related to the pharmaceutical organic chemistry also. And if you like the content of this my channel, you can subscribe to my YouTube channel, share with your friends to get more videos related to the pharmaceutical organic chemistry too. Let's begin with our today's session. Now first we will discuss what are the learning outcomes of this session. They are same as our previous video. After this video, students will be able to explain the Baeyer strain theory and explain the different advantages and the limitations or disadvantages of Baeyer strain theory. Now, as we know, in previous video we have seen how to calculate the angle deviation in the cyclopropane, cyclobutane as well as the cyclopentane. Now we know in cyclopropane the deviation is 49.5, in cyclobutane it is 19.5, and in case of cyclopentane it is about 1.5 degrees. Now as a result of this, the strain is more in cyclopropane, that is the 49.5, compared to the cyclobutane which is having 19.5. So first we will compare the stability and reactivity of cyclopropane and cyclobutane. Then we will compare regarding the all other molecules. Now it will make, because strain is more in cyclopropane, and due to which it will make cyclopropane less stable than cyclobutane, because what he has proposed, Baeyer said that if this deviation is more, obviously that particular compound will be having less stability. So here cyclopropane, as it is having the more deviation, that's why it is less stable as compared to the cyclobutane. So cyclopropane easily undergo ring opening reactions as compared to the cyclobutane. Means you can say reactivity of the cyclopropane is more as compared to the cyclobutane because its stability is less. So according to the Baeyer, the relative order of stability for some common cycloalkanes is as under. Means what, depending upon that, what he has proposed, cyclopentane is having more stability then as compared to the cyclohexane. Now in case of cyclohexane, what he has said that the bond angle is 120, and by using same formula, if we calculate the deviation in cyclohexane, that is the 109 minus 120, that is the minus 11, so minus 5.5 on each carbon atom, or if we compare both, that is the minus 11. So again, what assumption that he has made, that the higher rings which are having a negative bond angle or the angle strain, and that due to which negative angle strain, such a rings does not exist. So but when he has proposed this particular theory, the cyclohexane molecule was not known, but later it was found that cyclohexane, this is the naturally available molecule which will be having, and that can be isolated, which is having two different conformations that already we have discussed, that is the chair conformation as well as the boat conformation. So according to the Baeyer, the relative order of stability is cyclopentane is more stable as compared to the cyclohexane, as compared to the cyclobutane, as compared to the cyclopropane. But actually this order or the whatever the things that he has proposed, in that case the stability of cyclohexane is more. Practically if we consider, cyclohexane molecule is more stable. So here this theory unable to explain the relative order of stability, because actual observed order of stability for these cycloalkanes is under. As I said, the cyclohexane is more stable practically as compared to the cyclopentane, then cyclobutane and cyclopropane. So he was correct in explaining the stability of cyclopropane, cyclobutane as well as the cyclopentane, but not about the cyclohexane. So in this regard, what he has proposed, that the cyclohexane molecule or the higher molecules like cycloheptane, octane, nonane, decane, so these all cycloalkane molecules, as they are having the negative angle strength, such a molecules does not exist, and all these molecules are existing and they are practically isolated. Few of them are practically isolated also. So in this regard, that Baeyer was wrong. So according to the Baeyer, the bond angle in cyclopentane is 108. The geometry is pentagonal, that is very close to the tetrahedral angle, so it is almost free from the ring strain. Baeyer also proposed some facts for cyclohexanes that stood incorrect later on. As I said, cyclohexane is unstable ring due to the higher ring strength. He has also proposed that the rings more than cyclohexane, such a rings are also having higher ring strength, and as the ring strength is negative, such a rings does not exist. Also what he has proposed, it is difficult to synthesize the cyclohexane molecule and the higher ring systems as a deviation from normal tetrahedral value would be larger. So according to him, what he has assumed, for larger molecules this deviation will be more, so it is very difficult to carry out the synthesis of such a rings, and the larger deviation will result into the more strain and the ring systems will be unstable. But whatever these statements that he has proposed, all these statements were wrong. That has proven, because all cyclohexane molecules, heptane molecules, all these rings are very stable. They are isolated also. So in conclusion, Baeyer proposed that ring systems smaller or larger than cyclopentane or cyclohexane are unstable due to the higher ring strength, and cyclopentane is more stable cycloalkane that was found. Therefore, he has assumed that cyclopropane and cyclobutane easily undergo the ring opening reaction, whereas larger ring systems are difficult to synthesize. So these are the different assumptions that he has made, or he has proposed things. So cyclopentane is more stable, he is having higher stability. Cyclopropane and cyclobutane are less stable, they undergo easily ring opening reaction, and cyclohexane and higher rings are difficult to synthesize. Also Baeyer explained that synthesis of larger ring is difficult, but here you have to note that Baeyer was incorrect in presuming that larger ring systems are flat. So what he has assumed, that all the cycloalkane molecules, whatever the carbon atoms are there, all the rings are planar in nature or they are flat. Here he has done that particular mistake. It is difficult to explain the formation of larger ring system on the basis of angle strain, because larger ring systems are not flat or planar. That was assumed by the Baeyer. So here he was wrong. Larger ring systems are not flat or planar. Actually they are present in the puckered form or wrinkled form. Means whatever the carbon atoms that are involved in the benzene, in cyclohexane, all 6 carbon atoms are not in one plane, and these larger systems are present in puckered, which are also known as the wrinkled, to eliminate the possible angle strain. And in that case, cyclohexane as well as the large molecules, they maintain exactly the bond angle to 109, which is of the tetrahedral geometry or the tetrahedral bond angle, and that's why these rings are stable, and also we can carry out the synthesis of these particular rings also. If we want to synthesize large ring systems, then the open chain should be long, but in this case it is difficult for both the ends to join and form the ring. Means these are the different things that Baeyer has already explained, and also according to him, as large ring systems are not we are not able to synthesize these large ring systems, but if we want to synthesize these large ring systems, then the open chain should be long, but in case it is difficult for both the ends to join and form the ring, because we know in the methods of preparation of cycloalkanes we have seen most commonly used method for the preparation of cycloalkanes is that from the terminal halogen compounds, dihaloalkanes, where the removal of the halogen is carried out, and whatever the terminal carbon atoms are there, they are joined there, and due to which there will be formation of ring will takes place. So in case of the large ring system, there is a difficulty to carry out the synthesis in such a way that, because open chain should be long, but in this case it is difficult for both the ends to join and form the ring. Sometimes what happens, instead of joining of the terminal carbon atoms, the carbon atoms that are present in the middle, they may get joined. Now instead of this, end of an open chain will join with end of another compound and result into the different compound. Although it is difficult to synthesize large rings, according to the Baeyer theory, there are several methods for preparation of the large rings. Actually, there are two ways by which we can prepare these larger rings. Now, such methods are carried out in very highly diluted solutions of dihalides, in which the chain lengthening reactions would not occur, but ring closing reactions will take place. So this is the one way by which we can carry out the synthesis of higher rings as compared to the cyclohexane. So in this case we have to just use the very or highly diluted solution, so that we can use this highly diluted solution of dihalides in which chain lengthening reactions would not occur. 5 and 6 membered ring systems, that is the cyclopentane and cyclohexane, are favorable to synthesize as they are large enough to free from the strain and small enough to closure the reactions. So in in concentrated solution we can carry out the synthesis of cyclopentane and cyclohexane, but if we want to carry out the synthesis of the higher molecules, then we have to use the very highly diluted solutions, because cyclopentane and cyclohexane, they are not too much having more size and they are not too much small. They does not have any strain large enough to free from the strain, and they are not small enough to closure the reaction. So in this way we can carry out the synthesis of the large molecule. So these are the various facts that he has proposed. Now whatever these facts that he has proposed regarding the stability of cycloalkanes, this can be confirmed with the help of this study that is known as the heat of combustion. So that what is the effect of heat of combustion and how the stability of cycloalkanes can be confirmed with the help of the heat of combustion, as well as the advantages and the limitations of Baeyer strain theory, that we will discuss in the next video. Thank you. If you have any queries related to the pharmaceutical organic chemistry, then you can contact me on this particular mail ID. And if you like the content of this video, then like my videos, watch my previous videos also, share with your friends and subscribe to my YouTube channel. Thank you very much.